Okay, so we've gone over all the properties of logarithms and exponentials. Now we're going to see how do you solve equations using everything that we've done. So solving equations, and this is kind of a big point of everything we've done. So we've gone over all these properties so that we can solve equations for x. So just kind of a hint, I think this is a general hint and pretty good advice, is that first of all, if x or t or whatever your variable is in the exponent, then you have a couple different options. You can write everything with a common base, so write everything with the same base, or you can write everything with the same exponent, and we'll do examples of these, or you can go to log form. So that's my advice. If x or t or whatever your variable is in the exponent, you can either go to log form or write everything with the same base or write everything with the same exponent. And we'll see this. Or if x or t or whatever your variable is inside the log, then go to exponential form after simplifying. So when I say after simplifying, this is when all of those properties of logarithms are going to come in. You want to be really comfortable with all of those so that you can simplify. As a reminder, when I say go back and forth between these two forms, remember log base b of a equaling c is the same thing as saying b to the c equals a. So you want to be able to go back and forth between these two forms. So all of this is going to help us with solving equations. So let's just go through a bunch of examples. Let's say I want to solve for x. 3 to the x equals 1 over 27. So here, my variable x is in the exponent. So I can either write everything with the same base, I can either write everything with the same exponent, or I can go to log form. Let's write everything with the same base. So my common base here is 3, because 27 is a power of 3. 1 over 27 is 3 to what power? 3 to the negative 3. So all I've done is written 1 over 27 as 3 to the negative 3. Now that I have the same base, I can set the exponents equal. So this is x is minus 3. So that's one way to do this. The other way to do this problem is to go to log form. If I go to logarithm form, this says that log base 3 of 1 over 27 is x. Right, so I took this equation, this was in my exponential form, put it back into log form. That was what I just wrote before this example. What's log base 3 of 1 over 27? That's negative 3. So negative 3 is x. Now, it doesn't matter which way you do it, you're going to get the same answer. But you can go to log form, or I could just write everything with the same base. This is probably the easier way to do it, but it's up to you. Next example, 2 to the x plus 1 is 1/4 to the 2x minus 3. Now I have x in the exponent, so I can either go to log form, I could write it as the same base, or write it as the same exponent. I think for this one we want to write it as the same base. So can I think of a way to write 2 and 1/4 in terms of the same base? Well, I think 2 might be the best base to choose. So can I write 1/4 as a power of 2? So 2 to what power is going to give me 1/4? Well, 2 to the negative 2 is 1/4. So all I did was replace 1/4 with 2 to the negative 2 because now I have a common base. So on my left-hand side, I'll have 2 to the x plus 1. But what do I do with this negative 2 to the exponent? Remember, an exponent to an exponent, you multiply. So this will be 2, and when you multiply, make sure and distribute to the negative 4x plus 6. Now I have the same base, so I set the exponents equal. So I'll get x plus 1 equals negative 4x plus 6. This is an equation I can just solve for x. So I'll move my negative 4x to the other side, and I'll move my 1 to the right-hand side. So x is equal to 1. So whenever you have these problems where x is in the exponent, writing it as the same base is a good idea. Let's see, how about the square root of 6 to the t power is equal to 36 squared. Again, I have my variable in the exponent, so I can write it as the same base, same exponent, or write it in log form. Let's try to write it as the same base again. So what base am I going to choose, where I have a 6 over here and a 36 over here? Well, how about 6? So let's start with the left-hand side. How am I going to write the square root of 6 in terms of 6 to a power? This is really 6 to the 1/2. So the square root of 6 is 6 to the 1/2 because I'm trying to write it in terms of 6. What about 36? If I'm going to write 36 as 6 to a power, that's 6 squared. So I wrote everything in terms of 6, and now I have a power to a power, so 6 to the 1/2 t is going to be 6 to the 4th. I multiplied these two, write this up here, and now I have the same base, so I set my exponents equal. So 1/2 t is equal to 4, which means 2 is equal to 8. So an important thing when you're doing this is kind of notice what common base can I actually use. How about x to the 5th is 3 to the 15? Now here I don't have x as an exponent. Now I could go to logarithm form if I wanted to, but let's just try to write this as a common exponent. So can I put on the right hand side something to the 5th power? Because if I have the same exponent, then I can just set the two bases equal. So can I write 3 to the 15th as something to the 3rd, or something to the 5th? Sure, I could write this as 3 cubed, because 3 times 5 is 15. So that means that x is 3 cubed, which is 27. So here I wrote everything with the same exponent and set the bases equal to each other. Okay, now how about log base 2 of x plus 1 plus log base 2 of 8 is equal to 4. Here my variable is inside of my logarithms, so what I'm going to do first is try to simplify this problem as much as I possibly can. So on this side I have log base 2 in both terms, and they're being added. If I have log base 2 in both terms and they're being added together, what I can do is make this one logarithm where I multiply on the inside. Okay, now what does this say if I go to exponential form? That says 2 to the 4th is equal to whatever's on the inside. Alright, 2 to the 4th, what is that going to be? Let's see, 2, 4, 8, 16. How do you solve this for x? Well, you could distribute, or you could go ahead and divide by 8. So I'll get 2 is x plus 1, and then subtract 1 from both sides, x is 1. So in this problem, I started with logarithms where my variable was on the inside. I simplified it as much as I possibly could, so that was this step. Then I went to exponential form. So if you're in log form, go to exponential form, solve for x that way. Okay. What about 2 log base 3 of x minus log base 3 of x plus 1 is equal to log base 3 of 9. So how could I possibly do this one? Well, my variable is inside my logarithms, so what I want to do is simplify and then go to exponential form. So first of all, what am I going to do with this 2 on the outside? I can't combine these terms. You want to combine them via the quotient because I have the minus here, but that 2 kind of messes it up. So whenever you have a coefficient, remember you bring that inside as an exponent. So this is log base 3 of x squared minus log base 3 of x plus 1 is equal to log base 3 of 9. Again, I couldn't just divide these two automatically because of that 2. So I put the 2 on the inside as an exponent, and now I have a better subtraction because they're just log base 3's. So whenever I have the same logarithm with the same base, I combine them as 1, or I divide. So this will be log base 3 of x squared over x plus 1. What about my right-hand side here? What is log base 3 of 9? So that says what power do I raise 3 to get 9? That would be 2. Now what do? I've simplified it as much as I can. Let's go to exponential form. Exponential form says 3 squared equals the inside. So 3 squared equals the inside. Now how are you going to solve this for x? Well, let's move the x plus 1 to the other side. So I'll get 9 times x plus 1 is x squared, which tells me that 9x plus 9 is x squared. So this is a quadratic. How do you solve quadratics? You solve quadratics by setting it equal to 0 and then using your quadratic formula. So this is x squared minus 9x minus 9. So I move these two terms to the other side equals 0. Now use your quadratic formula. So negative b plus or minus square root of b squared minus 4ac all over 2a. If you do that, you're going to get two numbers. You're going to get negative 0.908 and 9.908. So I got two answers. Let's double check though. Can I actually plug in both of these? Can I plug in a negative 0.908 to this top equation? No, if you plug in a negative number right here, it's undefined. Remember, the log is only defined for positive numbers. So this is not a solution. So my only answer is 9.908. So for the logarithm, I simplified it as much as I could, so that took 2 steps. Then I wrote it in exponential form, solved for x using the quadratic formula because I had an x squared term, and then I plugged back in just to make sure, because the negative 0.908, you can't plug that in because the log is not defined for negative numbers. Go back to the graph. You can't plug in a negative x. So I got x is 9.908. Okay, 2 more examples here. First one, what if I have 10e to the 2x equals 50? Well, first thing I can do is let's divide both sides by 10. I can't go ahead and write this in logarithm form yet because I have this extra coefficient. So I have e to the 2x equals 5. Now the question is, what do I do to both sides? Well, whenever you have an e like this, or a base in general, you can go to logarithm form, or you can use the fact that the natural log is the inverse of the exponential. So I'm going to take the natural log of both sides. So if I take the natural log of both sides, let's look at the left-hand side. What's the natural log of e to the 2x? Well, those are inverses. This is like doing something to x and then undoing it. So all that's left is just that exponent. Remember, this comes from the fact that natural log of e to a power is just that power. So this is equal to natural log of 5. And now how do you solve for x? Just divide by 2. Natural log of 5 is just a number. You can plug that into your calculator, so don't treat this like a variable. This is just a number. So whenever I had the equation like this, I could go to the log form, and that's fine, or I could just apply the inverse. So here it was easy just to apply the inverse. And then lastly, what about e to the 2x minus 1 equals 3 e to the x? Now again, I have x in my exponent, so I could go to log form or try to write it as the same base. But what happens if I just take the natural log of both sides? So natural log of e to the 2x minus 1 equals natural log of 3 e to the x. So on the left-hand side, go back to this property up here. I do natural log of e to any power, it's just that power. So this is just 2x minus 1. What about this right-hand side? Can I just say that's x? Well, no, I have this extra 3 here. So what happens to that coefficient? Go back to your properties. I have multiplication on the inside, so split it up as addition. So I have natural log of 3 plus natural log of e to the x. Well, now what do I do? Well, natural log of 3 is just a number, so I can't really do anything to that. But what about natural log of e to the x? Go up here. Natural log of e to anything is just that anything. So this is just x. I have x's on both sides of the equation, so I'm going to move this x to over here. So I get x minus 1 is natural log of 3. Remember, natural log of 3 is just a number. Don't treat it like a variable. So x is natural log of 3 plus 1. Now you could definitely plug that in your calculator and get a decimal approximation, but this is what it would be in exact terms. So go back to the beginning of this problem. I had e to the 2x minus 1 equaled 3 e to the x. So I had x in the exponent, so I want to use something with logs here. Remember, that's what I said. So let's take the natural log of both sides. On the left-hand side, that simplified pretty nicely because of this property up here. Natural log of e to anything is the anything. But on the right-hand side, I couldn't do that just yet because of this 3. So I split it up and then applied that property. Then from there, I solved for x and got natural log of 3 plus 1. So just remember, if I have x in the exponent, you're going to have to use a log to get it out. Or you're going to have to write it as the same base. If I have it inside the natural log or the log, you're going to have to go back to exponential form. So just kind of go back and forth between those two. It's really important you're comfortable going back and forth between those two.